Hey class, today we're going to learn calculus.
In one day?
Yes.
Okay.
Here we have our two variables that we'll be using a lot, x and y. The value of x determines the value of y.
You make me who I am.
I know I do. You're not stupid.
Why do we have this division between us? Can't we just have a functioning relationship?
Because I've reached my limit.
You say that like it's one-sided.
Do you derive some sort of sick pleasure from what's going on between us?
I feel like I shouldn't be watching this.
Our next test counts for 50% of your grade.
I'm invested.
God, stop being so extreme. Can't you just listen to me every once in a while?
Is that really how you want our relationship to be? I feel like I'm chained to you. I just obey all your rules.
It really feels like something has changed between us. I mean, things are still changing. Our rate of change, calculated by,
Change in y over change in x.
is changing by the minute we're so different.
But consider the beginning of our relationship. It hasn't been all that bad, right? If you calculate the average rate of change, which can be found using
F of b minus f of a over b minus a.
over the course of our relationship, it's not that extreme.
What does that matter? Live in the instant. You can calculate the instantaneous rate of change like so.
I don't know how to read this one out loud.
And that's what we should be doing right now. Not looking back. This is a critical point in our relationship.
I'm done with you.
Don't you walk away from me. This conversation is integral to our relationship.
You say that like it's definite.
Better than what you do, just approximating everything. God, you can't just sum this relationship up until there's nothing left.
You know what? Maybe you're right.
What? Do you really mean that?
Yes, but you have to learn that we can't just do whatever you want all the time. We have to reach a compromise, a midpoint.
I'll do whatever it takes. We can fix this.
I like that.
Is my grade really worth this?
Calculus is happening all around us and you don't even realize it.
What do you mean? It's just confusing numbers. How can that be?
It can be used to find the velocity of a diver jumping from a specific height or cars speeding across the highway. You can find the velocity equation by finding the derivative of the problem. Finding t would give you the time it takes for t to reach the maximum height. Make sure you remember that. And you can find the maximum height by plugging the result of t back into the original equation.
That's amazing. I never knew that before.
You can also use calculus to help solve for revenue, profit, and average cost. Let me show you how. Here are the formulas you can use to help solve. Lowercase x represents the number of the items sold of a particular product, and therefore it won't ever come out as a negative number.
That is so interesting. But what else is fun and cool about calculus?
Well, you can use a different method to find derivatives, logs.
What? How'd you do that?
The law of logs can go either way. You either split the variables or bring them together. Multiplication becomes addition, quotients become subtraction, and exponents are brought to the front. The rules are also reversible.
Wow. Can you do a problem for me?
Sure. Here's an example with a quotient. When you solve the problem, you split the numerator and denominator and subtract them before solving further.
I think I get it.
Did you know that derivatives have opposites as well, just like logs?
What? No, I did not. That's so cool.
Here, I'll show you. Here's an example of an antiderivative. This example, you need to bring the t to the numerator, making the exponent negative, and then add 1 to the exponent. Remember, you need to put the same value of the exponent on the bottom.
I got it.
Make sure you put a c at the end. Now let's solve backwards to find the derivative. Remember, these are opposites.
Oh wow!
Did you know that you can also use derivatives to find graphs?
Yes, we talked about this in class. I think it's so interesting that you can use the first derivative to find the critical points, and the second to find the points of inflection for a concavity. Are there other things we can use calculus to find? Maybe real-life situations?
Yes, we can use calculus to find the maximum area of fences to make sure we get our money's worth. It's called optimization. You use area formulas and derivatives.
That sounds so cool. Can you show me how?
No.
Sure, look at this example. Start off by using a helper formula to set up the problem, then isolate a variable depending on what's given. In this case, it is W. Now we solve for L. Now, we plug in L into the area formula, and that's how we get our maximum width. I think you know what to do now.
This will help out a lot on my test. Thank you. I never realized how amazing and cool calculus can be.